Good morning guys, my name is Adrian De La Cruz and today I'll be discussing the codes, line by line codes of binary search tree. So let's get started. So here we're making a class, an BST class with the constructor that is get a point uh, with an integer key with nodes left and right. So basically nodes left and right are like the pointers. Uh, it's either left or right where it's gonna go. So public node in data and main Java run. So output clear and then key equals data, uh, adding values to the variables. So making a node root for the BST, and then after that I'm giving a value with the root. So as the kanang and then uh, making a constructor to uh, change and add value to the root, because of course the root will initially be null because there isn't any added value yet. So then making a void, a delete key, so it's just um, which will root equals delete recursive root key. So it's a recursive that will so recursive delete function. Node delete recursive with node parameters node root and in key the way, and you are using the function to delete or use the delete recursive with node, and then checking empty. If yes, then you gonna proceed to the next statement. If key is less than the root key, then it will root to the left, which will traverse to the uh, left side of tree, or else it's gonna go to the right, and then as if it's go to the right, and else it will go to the middle. Not the middle necessarily. It will go to the only child because that is only the what's options left. So after that, okay, root key meaning he's gonna um, uh, getting the minimum value. So or selecting the minimum value uh, of the right subtree, and then root the uh, delete it for the root right, and then return the current value that was left as the root. So int min value node root. So it's changing creating with data type integer a min value with parameter node root that is initially min val root, and then changing the value of the min val variable to the root key. So, and then we will now proceed to the uh, conditional statements, and then if the condition is true, then we will return the value, the final value of the minimum value. So now another node to insert key is just using insert recursive. So now we're gonna be using the insert function, insert recursive, not the not the function, just the insert recursive but node. So insert, now we're gonna be using node. So basically insert recursive but apply the nodes. So now this will check if the conditional statement is true, then it will return the final value of the root variable. So then proceed to the next conditional statements that will traverse to the tree, and then check it to check it if the conditional statements are true, and if it is false, it will proceed to the else if function, and then go to the other uh, uh, side of the tree, which will be inserted, since we are using insert function here. So, and then after that, we're gonna return the final value of the root again. And then now we're gonna proceed to the method of in order traversal of this T. So in order in order, it initiates the in order traversal of the BST starting from the root. So it's gonna traverse starting from the root, and then in order recursive. So what this means that a recursive function, it will perform traversal of the binary search tree, and after that there is a conditional value that will print the values of the nodes if it is true. Now proceeding to search key, which is either true or false, it will just change the root value to the search recursive key, and then if root is not equal to null, if there is a root, then it will true, or else it will return as false. So now in node search recursive node root int key, in this function, so we're using again the search recursive, so which meaning we're gonna traverse again. So we're gonna check if root is equal to null. So if meaning or no null, there isn't any value, or the key is present at root. So if the conditional statements are true, then we will return the latest value of the root. So then another if statement, root key is greater than key, then return the value left key. So and then finally return the search recursive value with parameters root.right and the key. So finally we're getting into the main codes. So because since they are all just functions for a binary search tree that will be used here in our main to be outputted. So of course create an object class with object name. So making an instantiation to get this the BST class, which is named the top here. So now, so that it will record all or to call it. Now, using object name and then with action to insert a value 45, 10, 7, 12, 19, and 50. So since there are some values that are depending if which is the greater or the smaller, it will be placed on either left side or the right side. Now we're gonna reprint the BST created with input data left, root, right, 7, 10, 7, 10, 12, 45, 50, and 90 in order with this in ordered function. So it also calls the in order function, which was defined earlier before the main. So now we're gonna print again the binary search tree after delete 12 on the leaf node. So the binary search tree, calling it, and then action delete key function, which was called also in the before the main, and then value is 12, and then in order it to that. So to order it, and then the result is leaf node 7, 10, 45, 50, 90, and then proceed now to the BST after delete 90 node with only one child. So the tree now changes but it only has one child. So now after deleting the value 90, 10, 7, 10, 7, 10, 45, 50, and then proceeding it to deleting the 45 that has two children. Now the final is 7, 10, 50, and then boolean retrieve value equals binary search tree equals search the 50. So it will basically search where it is located. So key found in binary search tree and then equals red val, and then continue. So basically this is a boolean. Okay, so true or false. So it's either true or false if it's found. So red val equals BST search 12, and then key 12 found in BST. So since the 12 isn't there, so it will um, uh, come out as false. So I think that's the binary search tree, and thank you for listening and watching.